Out in a quiet harbor, far from headlines and heroics, she waits. A 100,000-ton giant of steel, once the pride of a nation, now sits motionless, rust streaking down her hull like fading war paint. This is not just a ship. It is a floating city. A symbol of power. A machine that once projected dominance across entire oceans. Years ago, building a nuclear-powered supercarrier cost nearly $4.5 billion. Thousands of engineers. Millions of parts. 2 nuclear reactors capable of powering a city. On her deck, fighter jets launched every few minutes. Below, over 5,000 sailors lived, worked, and prepared for missions that shaped global history. Now. Silence. The wind whistles through empty radar towers. The vast 4.5-acre flight deck stands bare. No roaring engines. No deck crews in colored jerseys. No aircraft screaming into the sky. This is what the Navy calls the mothball fleet, vessels preserved, but inactive. Maintained just enough to prevent decay, yet stripped of their operational soul. It's a strange limbo between retirement and resurrection. But here's the question no one asks. How does something this powerful become forgotten? Steel corrodes. Technology ages. Budgets shift. Newer ships arrive. And even giants are eventually sidelined. Rainwater pools along the deck where jets once taxied. Seabirds circle above the silent island tower. Inside, narrow passageways echo with nothing but the hum of distant ventilation fans keeping moisture at bay. Yet beneath the rust, the hull remains massive. The reactors may still hold life. The bones of this machine are intact. And that sparks a bold idea. Instead of scrapping her, what if we bring her back? What if the silence is only temporary? This is the story of restoring a ghost of the ocean, and turning silence back into thunder once more. Boarding an abandoned supercarrier is not like stepping onto a museum ship. It's entering a dormant industrial labyrinth, a massive steel organism frozen in time. Engineers arrive wearing protective suits, respirators, and gloves. Years of inactivity can conceal dangers, toxic mold, corroded pipes, and unstable compartments. Every step echoes through cavernous hangar bays that once housed entire squadrons of fighter jets. The silence is almost palpable, broken only by the faint squeak of metal underfoot. Lights flicker on for the first time in years. Dust drifts in the narrow beams of flashlights, catching on cables and ladders. Miles of passageways twist and turn below deck, over 3,000 compartments connected by steep ladders, watertight doors, and maintenance hatches. The initial inspection focuses on structure, the ship's skeleton. Ultrasound devices probe steel thickness, and engineers scan support beams for microfractures. Saltwater corrosion is the greatest enemy, invisible, slow, and relentless. The hull must be solid, if not, restoration ends before it even begins. In the hangar bay, the vast emptiness reveals both promise and decay. Paint peels from bulkheads. Hydraulic lines hang stiff and brittle. Machinery lies dormant, layered in dust, yet hints at the power once harnessed here. Electrical systems may be compromised. Old insulation could contain hazardous materials. Fire suppression systems might no longer function. Every inch must be documented meticulously. Photographs, notes, and diagrams form the blueprint of knowledge that will guide the restoration. This phase alone takes months. Engineers crawl through narrow shafts, climb ladders, and squeeze into compartments the size of closets. Because before you restore a giant, you must first know whether it still has a heartbeat. And as inspectors move deeper into the ship, the verdict begins to form. The bones are aging, but they are still strong. The ghost may yet rise. At the heart of the supercarrier lies its most powerful, and most dangerous, component, the nuclear reactors. Unlike conventional ships, this carrier doesn't rely on diesel fuel or traditional engines. It runs entirely on enriched uranium, carefully sealed inside two massive reactor cores, capable of operating continuously for years without the need for refueling. These reactors were once capable of generating enough energy to power an entire city, a silent testament to human engineering. But after decades of dormancy, one pressing question dominates every mind aboard: are they still viable? Accessing the reactor compartments requires the strictest safety protocols. Radiation monitoring devices are activated. Protective shielding is meticulously inspected. Engineers move slowly, deliberately, aware that every reading, every movement, could have consequences. Nuclear systems are built for durability, yet time leaves its mark. Seals deteriorate, coolant systems corrode, insulation degrades, control rods stiffen. Even minor degradation can escalate into major risks. If the reactors require refueling, the process alone could take years and cost billions. Specialized dry docks, certified technicians, and multiple layers of regulatory approval would be mandatory. Inside the reactor room, the air feels heavy, not from radiation, but from responsibility. Thick steel containment vessels still stand solid, a reminder of the ship's enduring strength. Cooling systems are examined for signs of corrosion. Control systems, once entirely analog, are now outdated and in need of modernization. The good news: nuclear carriers are engineered for longevity. Many operate for 40 to 50 years with proper maintenance. If these reactors pass inspection, restoration shifts from a distant dream to a feasible mission. If not, the entire project could collapse under its own cost and complexity. This moment defines the future of the ship. After weeks of painstaking testing, detailed data. Moving a 100,000-ton supercarrier is not simple. Tugboats surround the silent giant like ants guiding an elephant. Slowly, carefully, they pull her from anchorage toward dry dock, a massive concrete basin built specifically for ships of this size. The margin for error? Almost zero. Every maneuver requires precision measured in meters, each tugboat communicating in subtle tugs and gentle pushes. A single miscalculation could spell disaster. Guidance crews monitor every inch of movement. Powerful currents and unpredictable crosswinds threaten to push the hull off alignment. Even the slightest sway can scrape the dock or twist delicate components. The atmosphere is tense, radios crackle with constant updates. A mistake could damage both ship and dock, or worse, injure crew. As the carrier finally settles into position, massive gates close behind her with a resonant clang. Then begins one of the most dramatic phases of restoration. Pumps roar to life, a thunderous mechanical heartbeat. Millions of gallons of seawater begin draining from the dock. Slowly, the ocean recedes from the hull. For the first time in years, the full steel body of the carrier becomes visible. Barnacles cling like armor, marine growth blankets the underside, and rust stains stretch along the waterline like battle scars. This is where the real condition of the ship is revealed, raw, unhidden, and monumental. Engineers walk beneath the hull. An awe-inspiring sight. The scale is overwhelming. Propellers tower higher than a two-story building. Rudders are thick as fortress walls. Every inch is inspected with exacting care. Ultrasonic scanners measure steel integrity. Divers previously surveyed the hull, but now crews can physically touch and test it. If structural weaknesses are found, massive steel plates may need replacement. This stage determines structural survival. And as days pass, the assessment brings cautious optimism. The hull, though scarred by time and sea, remains remarkably strong.